Hello, everyone. Welcome to Daily Value. I'm William Wallace, and today I'll be introducing a topic that has been getting more and more press, and one that we don't fully understand, but the implications of which could play a very large role in natural health product development, drug development, and also have large implications for future health outcomes. That topic is the relationship between B group vitamins and the human gut microbiome. Recent research has begun to uncover the potential of B group vitamins as prebiotic candidates with the ability to alter gut microbiota composition in favorable directions and enhance metabolic functions. In this episode, we'll explore how B vitamins interact with our gut microbiome, why these interactions are significant, and what they mean for our overall health. Now, before we dive in, please remember that this podcast is for educational purposes only and does not replace professional medical advice. Always consult with a healthcare provider for personalized recommendations, especially as it comes to something like supplementation. First, let's start with what exactly is a prebiotic. The current definition of a prebiotic was laid out by the International Scientific Association for Probiotics and Prebiotics in 2016. They define a prebiotic as a substrate that is selectively utilized by the host microorganisms, conferring a health benefit. This allows us to say certain compounds like specific fatty acids or fibers or polyphenols from plants are prebiotics, and we can also say things that bacteria inhabiting different areas of our bodies use selectively can be described as prebiotics. It doesn't have to just be used by bacteria in our guts. The definition includes bacteria in other areas of our body, including our skin, our oral cavity, and even our genital organs. Now, interestingly, this puts vitamins in an odd space because they're not selectively used by bacteria, meaning that we, the host, also use relatively high amounts of vitamins for very specific purposes. However, there are more and more researchers coming out showing and saying that non-fermentable compounds like vitamins that influence the bacterial composition of our gut are adjacent to the concept of a prebiotic, meaning very closely related. Now, interestingly enough, our microbiota don't only use vitamins, but they also make some vitamins themselves, specifically B vitamins. B group vitamins include thiamine, vitamin B1, riboflavin, vitamin B2, niacin, vitamin B3, cobalamin, vitamin B12, etc., etc. They act as coenzymes in energy production, DNA synthesis and repair, and in maintaining neural function. Vitamin B1, that being thiamine, is an essential cofactor for all living organisms, interestingly enough. This has led to a larger discussion on what role, if any, our gut bacteria play in aiding our own daily intake of B vitamins. As we know, human cells cannot produce B vitamins, at least not all of them. We can produce a substantial amount of vitamin B3 from the amino acid tryptophan if we are in a vitamin B3 insufficient state. However, we cannot produce all B vitamins, and certainly not in sufficient amounts to cover all of our physiological needs. We also don't store B vitamins in very large amounts due to their water-soluble nature, which essentially means we need to have consistent intake of those things through our diet, or possibly rely on our gut microbiota to fulfill some of those needs. However, we do need to keep in mind throughout this discussion that although we may be receiving some direct benefits of B vitamin producing bacteria, that other intestinal microbial communities also use those B vitamins produced in the gut to colonize and survive, and in that way, we may also be receiving some indirect benefit through the growth and survival of bacteria that use those B vitamins through what's called cross-feeding. To restate that, in other words, certain gut bacteria produce B vitamins, which can then be shared with other microorganisms that lack the ability to synthesize these vitamins. The symbiotic relationship helps maintain a diverse and stable microbiome, which seems to be critical to our health. So now, in this way, B vitamins that we take in through diet might be having a dual effect, that being supporting our nutrient levels and gut health by acting as a kind of prebiotic. One of the primary controversies to the role that B vitamins play as a prebiotic is due to the fact that most vitamins we consume through diet are usually absorbed in the small intestine, not reaching the distal gastrointestinal tract or the large intestine, where many bacterial species that are B vitamin consumers tend to be located. However, there are preliminary studies in humans that suggest that when supplied in large amounts or as part of a specialized delivery format, like is the case with some supplements, that these vitamins can in fact reach the colon. The colon makes up a significant portion of the large intestine, and these vitamins have direct effects on microbiome of the colon. Another theory is that vitamins circulating in our blood can also make their way back to the intestines through normal systemic circulation behavior. But back to the colon to explain why B vitamin producers seem to be particularly important to our health. The colon is where most bacteria are in our body that produce very important molecules like butyrate. Butyrate is a type of short-chain fatty acid produced by certain bacteria when they break down things like dietary fiber. Butyrate is important because it provides energy to the cells in your colon, helps reduce inflammation, supports a healthy gut lining, and likely even has a positive impact on cognitive function. The highest concentrations and the most significant activity of butyrate-producing bacteria are found in the colon. Recent research on this topic shows that the most abundant butyrate-producing species in the colon are dependent on B vitamins provided by the diet or through cross-feeding with other bacteria that do produce B vitamins. Two examples of B vitamins delivered in either high amounts or through specialized encapsulations that do seem to be making their way to the gut to promote health effects and beneficial bacterial compositions in humans are vitamins B3, that's niacin, and vitamin B2, that's riboflavin. Riboflavin, or vitamin B2, is particularly interesting because it plays a significant role in energy metabolism and the generation of ATP, which is the energy currency of our cells and bacterial cells. Two studies in humans have indicated that when riboflavin is given in doses of 30 milligrams or more, that it may indeed be reaching the colon. For reference, the dietary recommended allowance of vitamin B2 is 1.3 milligrams per day for adult men and 1.1 milligrams for adult women. Many multivitamins on the market do contain amounts of riboflavin above that 30 milligram threshold. There was a pharmacokinetic study published in 1996 showing that the most vitamin B2 that can be absorbed through a single dose is somewhere around 27 milligrams, and that any more taken in a single time is likely to reach the colon. This led to a pilot study. I will emphasize it was a pilot study in Nature that gave 11 healthy adults 100 milligrams a day of vitamin B2 for 14 days. The researchers found that the amount of the bacterial species Faecalibacterium prausnitzii grew as measured in fecal matter over the course of the study and dropped again after a week once supplementation had stopped. Faecalibacterium prausnitzii is one of the most abundant and important butyrate producers in the large intestine, and it does not encode genes involved in vitamin B2 synthesis, meaning that the supplementation reaching the colon was likely to explain its increase in abundance. People who have irritable bowel disorders, particularly Crohn's disease, have diminished amounts of this bacterial species, so its abundance is implicated in states of good health. Another study published in 2021 showed that 75 milligrams of riboflavin in a specialized delivery capsule was able to reach the colon and improve the abundance of other butyrate-producing bacteria like those of the Clostridium genus. Now, to repeat in a simplified manner, the direct effects of the gut microbiome by B vitamins is complex and influenced by several factors, including the form, dosage of the vitamins, as well as the delivery mechanism. Given these insights, how can we leverage B group vitamins to enhance gut health? First, it's important to recognize that not all B vitamins will reach the gut microbiome when taken orally, as many are absorbed in the upper gastrointestinal tract. However, formulations designed for delayed or colon-targeted release might offer a solution ensuring that these vitamins reach the distal gut, where they can exert their prebiotic effects. Likewise, some vitamins supplied in high amounts may reach the large intestine when transporters in the small intestine are saturated enough to not allow for any more absorption into circulation. The research into B vitamins as prebiotics is still in its early stages. Future studies, particularly human clinical trials, are needed to fully figure out the mechanism through which B vitamins modulate the gut microbiome and to identify the most effective supplementation strategies. Despite their importance, B vitamins are water-soluble and not stored in large quantities in the body, making regular intake essential. But what happens when the gut microbiome is compromised? The absorption and synthesis of these vitamins can be significantly affected, making worse the risk of a deficiency. For individuals at risk of B vitamin deficiencies or those with compromised gut health, combining B vitamin supplementation with probiotics could be a promising strategy. In fact, an animal study published in April of this year looked at that very thing to see if co-administration of certain probiotics and B vitamins could be a viable strategy for improving the absorption of B vitamins in humans. And that, my friends, will be the topic of the next episode of Daily Value while we continue on with this theme. In conclusion, B group vitamins hold potential as novel prebiotics, capable of supporting both gut health and systemic well-being. As our understanding of the gut microbiome continues to evolve, these vitamins may become a key component of strategies aimed at preventing and managing various health conditions linked to the gut and the microbiome. Thank you for joining me today on Daily Value. If you found this episode insightful, please subscribe and share it with others who might benefit from this information. Until next time, stay informed and stay healthy.